Yeah, I think the aerospace presentation is next, if I'm not mistaken. George?
Good afternoon, Mr. Chairman, members of the committee. My name is Gary Pulliam, and I'm pleased to present to you today the initial look into Aerospace Corporation's work on this important subject. A word about aerospace. We are a California-based not-for-profit company formed in June 1960, 49 years ago this month, to provide technical and scientific support to Air Force and other government space programs. And that's the job we've been doing for those 49 years. We've been a strong partner with the Air Force and a strong partner with NASA for many, many years, and we're proud of that fact. With regard to this particular piece of work that NASA has asked us to do, we've been looking at the subject matter of the EELV system as a replacement for part of the constellation profile for some time, even before it became a profile. We began an initial look back in 2005 after the President had announced his vision, but before the architecture was well understood, and at that point we were simply asked to determine whether or not the EELV could be human rateable, and at that time we decided and determined yes, it could be. Then NASA came out with its architecture and proceeded along those developmental paths. Then about 3 years later, late last year, we were asked to look at it again now that NASA had begun its development of its programs, and now that the EELV, particularly the Delta IV, had flown, and now that NASA had implemented some of its own policies with regard to human rating factors and other matters, we were asked to come back and take another look at the state of information regarding human rating of the EELV, and we presented that information to the NASA headquarters to Dr. Griffin and staff in December. And then following that, we were given this final task, which is the last bullet there. Next chart, please. And the scope of that study was now to get a bit more precise and to look at the programmatic and technical feasibility of using a Delta IV Heavy in lieu of the Ares 1 mission, and specifically to look at that in the context of the overall effects on the constellation architecture. And that's a really important point for our work. We looked at the capability of using the Delta IV Heavy in lieu of the Ares 1 to take humans to low Earth orbit, and what that means to the rest of the constellation, and the intended mission of taking humans beyond low Earth orbit. So we did not look at alternatives to the job that NASA's been given. We did not look at alternatives to the architecture. Our study assumed that you want to leave low Earth orbit, and to do that you need a big rocket, and the big rocket of record is the Ares 5. We also did not assess the confidence levels or the executability of the current Ares 1 cost and schedule. We took the program of record and the progress that was initially established for the program and used those for comparability purposes. As we began to look at those, we came up with several options. First, we started with the Delta IV baseline program, which is not presently human rated. And then we began to look at excursions around that to bound our study. In option number 2, we looked at taking the Ares 1 upper stage and its J2X engine and using those on a Delta IV. We realized that the J2X engine, as being currently designed, has a good deal more thrust than this application would need. So that led us to an option number 3, where we would still use the Ares 1 upper stage with its engine, but at a reduced, resized level of thrust to be more appropriate for the mission at hand. Then we began to look at other kinds of upper stages. In option 4, we looked at a redesigned upper stage with a cluster of 4 RL-10 engines, and then we looked at could you do this mission with no upper stage at all, just using the Orion service module for final maneuvering, and then finally, what about the HR human-rated Delta IV with just a single RL-10 engine. We did not look at the Atlas V simply because the Delta IV Heavy was farther along. It had flown. We had more comparative data, so we concentrated our work at NASA's direction on the comparison of Delta IV Heavy to the Ares 1 program. As we completed this study, here are some of the top-level key findings that we have. First of all, as we understood how NASA was implementing the human rating requirements into the Ares 1 program, we were better able to make a determination about how these might flow into a human-rated Delta IV program. We tried to be as precise as we could and as comparable as we could as we made determinations about the Delta IV human rating program. The configurations that have either the J2X engine as the upper stage or RL10 derivatives are feasible, and they have significant margin in terms of cost, in terms of performance to both the International Space Station point and to the LEO point for the lunar mission, which is a bit more demanding. We also looked at the Delta IV human rated with one single RL10 derivative engine. We found that it meets the Ares 1 performance margins, but it is closer, as you would expect, one engine instead of a cluster of 4 engines. But we did find that it had sufficient gross margin performance for that mission. But we suggest that if the committee is interested in that particular option, that we need to be more precise and more work is required on the exact profiling of the launch and the ascent profiles and the performance margins to those very important targets. We looked briefly at the no upper stage configuration using the Orion service module, and our estimation and our findings are that while it could make performance to the ISS target, we didn't think it could make performance to the lunar target, which has a bit more upmass requirements. And so that was our findings on that. Next chart. As we looked at the constellation impacts piece on this possible trade, we believe that the industry can accommodate whatever increase in production might come from moving the Ares 1 into the Delta IV EELV human-rated family. However, we're quick to point out that the industrial base includes the large solid rocket motor industrial base, and that becomes a concern as we thought about the overall architecture at large. We recognize that the Delta IV Heavy can use some of the existing Ares 1 hardware infrastructure, ground processing and infrastructure, and we tried to take advantage of that in our assessments wherever we could. You just heard from ULA that they preferred Slick 37A. That would work. We actually preferred Slick 39 a bit more, but both those options are attainable depending on which way you wanted to go and how you worked the ground processing piece. The aerospace recommended option is for the human-rated Delta IV Heavy with a cluster of 4 redesigned RL10 engines. That gives an engine-out ability, which we think is important, and it allows a different kind of thrusting and orbit insertion, a different kind of thrust level than you would need with only one engine, and that became our recommended option among the 6 we looked at. It is important to recognize as well, and this plays into the remainder of our findings, once you make that decision to go with any combination of RL10 engines, assuming, as we did, that the Constellation program is still the program of record, which means you need a big rocket, and that big rocket is the Ares 5. Now you have to deal with what are you going to do about the solid rocket motor industrial base, and who's going to take care of the J2X engine development, as you would appropriately determine, because both the Ares 1 and the Ares 5 use the J2X engine, then those developmental costs are borne by the Ares 1 program. So if that went away, now that burden of developing that engine shifts over to the Ares 5 program, and we'll see that when our cost findings show up here in just a moment. Next chart. So the story now moves from the technical ability to use a Delta IV Heavy human-rated in a number of configurations to accomplish the mission, into what does it mean to the constellation at large. So we start out with the idea of we're talking about 14 flights to LEO, to the ISS and lunar orbit targets, and we're presuming that NASA's job is still to take humans beyond low Earth orbit to accomplish the Moon mission and eventually the Mars mission. So again, we did not attempt to change that architecture at all. If you went with one upper stage, one RL-10 engine upper stage, and delivery to those 2 orbits, we believe that you could save about $6 billion relative to the Ares 1 program of record. Remember that we believe the performance margins there are a bit closer than they would be with our recommendation of 4 RL-10s. If you move into our recommendation of the 4 RL-10s, we find the savings to be about $3 billion from the Ares 1 program of record. And if you decide you're really going to use the Ares 1 upper stage with the J2X engine on top of the human-rated Delta IV, we think the cost comes out about the same in that trade. But immediately one must recognize for all those options, there are some increases in the present cost profile for the Ares 5 program. Particularly if you choose an option that does not have the J2X engine, then those costs are going to shift to the Ares 5 program and have to be borne by it in order to have the J2X engine ready for that rocket. So we find that those cost uppers for the Ares 5 program would be somewhere between 1.1 and $3.6 billion, depending on which of these other options you choose and period of implementation and some of those details. If one cancels the Ares 1 program, NASA asserts to aerospace, and it was a given in our study, that it has to add back a substantial amount of funding in order to accomplish the constellation architecture mission as originally given to them. You can see in the final bullets there are elements of that number that NASA's given to us of between $14 and $16 billion. There are industrial base issues there. There are sustainment of the workforce issues. There are the increased cost of development of the J2X if you're now not doing that under the Ares 1 program. We've called out one of those elements in the middle bullet there about increased DDT&E cost of the Ares 5 program. Those costs might be partially or perhaps even fully accounted for in NASA's number, but the point is NASA has confirmed that if we went to the Delta IV Heavy, they believe at this moment that they would have a requirement for this much additional money back into the program to accomplish the mission they've been given. Next chart, please. With regard to schedule, we believe that human rating of the Delta IV is on the order of 5.5 to 7 years. That is aerospace's conservative estimate. No doubt there's some time in there to get started. The go-ahead for that would certainly not be today. And we've done conservative things as you would expect us to do as we contemplated historical times for human development activity, and we believe it's in the range of 5.5 to 7 years. We did not compare that in a date on the calendar to what Ares 1 is doing. We accept the IOC as presently given for the Ares 1 program, and this is simply a statement of how long we think this program would take. We think the ground facilities and the launch vehicle components actually are pretty close to the critical path. Both of them are going to take some amount of time. We think Orion need not be on the critical path because it's farther along, and if you want to redesign a new upper stage, you can shift the preponderance of that technical burden over to the new upper stage and try to disrupt Orion as little as possible. So we think there's a way to work that. With regard to the Ares 5 schedule, it again depends on programmatic and program management activities. With more time for the Ares 5 program, the schedule actually could be positively impacted. But if, on the other hand, NASA were to cancel the Ares 1 program and wait a long time before it turned its attention to the Ares 5 program, it could actually be damaged. So the opportunities there exist to actually help the Ares 5 schedule. We see nothing inherent about using a Delta IV Heavy that detracts from the Ares 5 schedule other than one now needs to really pay close attention to this industrial base issue to make sure those capabilities are there for you when you need them. Same with the Orion schedule. NASA's indicated to us that if you move the Orion over to a new or redesigned upper stage, it might take as much as a year to revalidate, recertify, requalify the interfaces. Even if you're not redesigning that capsule, you need to now make sure it's going to fit on the new upper stage that you've decided to do if you put it on a Delta IV instead of the Ares vehicle. And we would say that in all cases, if such a decision were made, those decisions need to happen immediately so that planning can begin and long lead items can occur and all the things that would be required not to have that schedule slip. We were also asked to contemplate what the effects might be on national security space. And again, it could be positive and it could be detrimental depending on your point of view. Certainly, more production of EELVs for more than one customer would serve to bolster supplier chain robustness. It would have the opportunity to bring down costs for all customers potentially. It perhaps would get suppliers and factories running back closer to the kinds of capabilities and capacities they had in mind when they designed those. On the other hand, as was mentioned by both previous briefers, you could wind up with two configurations of the Delta IV Heavy in the same plant. One would have to understand what differences those make if the human-rated Delta IV is is a slightly different vehicle than the non-human rated, then those issues would have to be managed. We think they could be, and that would be easily accommodated. You could wind up with a single vehicle that accommodates both users, and one would have to really understand what the payload capacity is for that vehicle in light of all of the missions that it now has to do on behalf of national security space programs. We think that the idea of national security space and NASA working alongside could be managed to the good of the nation, but it would be something that everyone would need to pay attention to. And we think the pad and range issues, regardless of which pad you go to, are manageable and doable, as both presenters prior to me have indicated. So finally, just to reiterate, that the constellation architecture as designed by NASA in 2005 is an architecture, and it behaves like an architecture. The Ares 1 program feeds into the Ares 5 program. Developmental costs for engines are borne in the early part of the program and then used in both segments of the program. So when one starts contemplating replacing pieces of that architecture, all kinds of things begin to happen, as you see here. You see industrial sustainment cost, workforce issues, perhaps pad issues that you hadn't contemplated. So when viewing the particular small slice of can the Delta IV Heavy take humans to low Earth orbit for less money than the Ares 1, the Aerospace Center answer is, depending on which option you pick, yes. Quickly followed by, are you still going to build an Ares 5, and do you still want to maintain that infrastructure, at which time, frankly, the total cost of the total mission for NASA depends heavily on what NASA needs to do to sustain that program, should such a decision be made. Mr. Chairman, it's my pleasure to present this initial look into our work, and I'd be happy to entertain your questions.
Thank you very much. We've got, I think, just a couple of minutes if anybody has questions.
I have a question, Norm.
Okay, fine, we got two here. I saw both.
You go first this time. Okay.
All right. I've got two, but they're quick. I just want to make sure I'm not misreading what's in here.
Okay?
The no upper stage option for the existing Orion capsule, that's the same service module that was already previously planned. Is that correct? And it just burns to do the rest of the Delta V. If it were true that we had the ability to do on-orbit propellant supply, then you could also do the next piece of the mission by putting the gas back in, right?
Looking at my expert across the room. Yeah.
Okay.
We didn't study it for this. But
Okay, no problem. And the second very quick one is, you said that this 5.5 to 7 year human rating development time is based on the past historical experience, but the only past historical experience I can think of is when we put people on the original Atlas and the original Titan. What did it take to human rate those vehicles?
Can you help me, Ray?
Well, it went through much the same process. They had to look at things like redundant actuators on the engines, they had to look at structural margins, things like that.
But it took 5.5 to 7 years?
Yeah, I think that those were done much more quickly under the circumstances, but we base it on what they have looked at for the human rating of other systems, but also it's just simply the development of recent space systems, how long it's taken, is
Thank
part
you.
of what we looked at.
This is Mr. Ray Johnson, who manages our entire group for launch vehicles at the Aerospace Corporation. So it is a conservative estimate. We'd be delighted if it were less than that, but as we looked at the things that we think go into it and how long we would take, we came up with that band of 5.5 to 7. Yes, sir.
Yeah. The question, if you replace Ares 1 with Delta IV Heavy, production of solid rocket segments goes from, to support a shuttle, around 50 a year. For Ares 1, it drops down to some smaller number and then later picks up when you bring on Ares 5. In this scenario, and I don't know if you guys had a chance to look at that, if you, let's say, propose and get a Delta IV to fly to ISS, you essentially went to cease production of the solid segments until you ultimately start needing it for Ares 5. And the question is that possible? We are killing a country's capability to do those solid motors?
There you put your finger right on what we believe is one of the critical issues surrounding any alternative one might choose. And you've said
Did you have it in your briefing, or I missed it, I guess, if you did.
We did do some work on that, which will hopefully be releasable when the more detailed work comes out. We do acknowledge, exactly as you said, that now there are two primary manufacturers of solid rocket motors, and only one of those that is the manufacturer of large segmented solids. The Ares 1 is intended to have a 5-segment solid. The Ares 5 is intended to have a 5.5 segment solid. So that is all understood from an industrial capacity. If you cease building the Ares 1, then the big question becomes, do you still need to have the ability to produce segmented solids in a few years? And if you're going to build an Ares 5, the answer to that is yes. So then the next question becomes, how do you do that? And NASA can give you the particulars, but that is a key factor in that number that they believe is required of them to sustain that kind of capability over the years. So one can take excursions on other ways of doing the large rocket, but again, for purposes of our scope for this program, we did look at that. We understand that if you, from a capacity perspective, if you stopped building segmented solids for a while until you needed them, that the resultant capacity in that industry should be viable, but I'm not the person trying to run that industry. I mean, the other supplier of that industry operates at about the level that the first supplier would wind up at, but what happens to the people and the tools and the artisans and the techniques and the recipes and the strike and missile defense area certainly would not sustain both those suppliers. So we believe that if one is serious about moving away from the Ares 1, that there's still a bit of work to do there so that we really understand the effect of large segmented solids.
Yeah, just wondering if you had done any PRA for loss of crew, loss of mission using this configuration?
We did not consider that for this one. It was more of a technical cost and schedule feasibility study.
Okay, thank you.
Mr. Chairman, just a information request. Clearly, this 5.5 to 7 year human rating timescale is a very important timescale. I'd like to ask if we could be given by Aerospace more detail on the origin of that number, perhaps something in writing explaining the origin and
As
scale.
you might expect,
Thanks.
enormous technical underpinning to all of these, and while we're pleased to bring to you what is releasable today, we recognize that the committee might desire to get some of the details behind these. We'll be happy to do that.
Gary, I had a similar request that relates to the industrial base backup data
Yes, sir.
and the human resource backup data.
Be happy.
Thank you very much.